Hi everyone, welcome back. If you're liking what I'm doing, please just press like, and if you get a chance, press subscribe. Looking at the basics on only sine and cos when we reversed the differentiation, which is called anti-differentiation, which is then later called integrate. So I'm going to go straight to the integrate sign. If you're brand new at this in year 12 somewhere, or maybe in year 11, and they'll talk about anti-differentiate, that means anti-differentiate. It's got other things that means later on if you've not done them as yet. It talks about the area under a curve and calculating areas and all sorts of things. But for the moment, it's just the basics. A couple of years ago, one of my students helped me think through. I've always done this in my head, but I've never written it down. So when you differentiate sine, we're talking here about differentiation. A sine becomes a cos becomes a minus sine becomes a minus cos, and a minus cos becomes a sine. They go around the circle. I could draw up sine graphs and do another video and show from common sense, not from proof, but then we can show from proof as well. So at the moment, we're just going to go through the basics of what that means. Now, we're going to do the reverse of that. I could put other arrows on, but it's simple enough to think if I have a cos, where did it come from? The sine. So in this question here, I've got a cos, and where did it come from? It came from a sine. Now, I haven't finished the question. Don't forget to put plus C. In the Western Australian exams, you don't put plus C, you might lose a mark somewhere in the paper. So I talk about this 3 here. The 3 is there. I call it for the ride. There's no such thing as for the ride, but you'll hear me talking about for the ride. I want things to be really simple for your brain. So this is like doing a cos curve, a cos function, but it's going to be 3 times as tall. 3 times as tall, or 3 times stretched out. And talk about 3 times stretched out vertically, so we're back into dilation by a factor of 3. So it's going to change all the numbers. So if I didn't have a 3 there, it would just be a sine, but with a 3 there, it's got to be a 3 sine. There's nothing else I have to do to that function. That is the answer to it. That is the integral of that, and sometimes it's referred to as the primitive function. And when we talk about primitive function, it just says all we've done is said, where did that come from? It came from that function there. So next one, same thing, didn't make anything more complicated, it's got a 10. Then you say, where did sine come from? Where did sine come from? It came from a minus cos. So I tend to write the cos first and put the minus on there. Nothing else has to happen, you don't need to increase the powers, don't change the powers, there's nothing to do with that here. We're just saying, where does the sine come from? Comes from a cos, and I could draw up the graph and show you. So a little bit more complicated, this one. Tried to make it fairly obvious things again, but this time I've got this extra 3 in here and this extra 10. Let's have a look what happens. I still talk about that 4 is there for the ride, so when I talk about for the ride, I keep it as a single arrow. So if you get used to my methods, where the cos comes from, a cos comes from a sine, so that becomes a sine. Now here's the interesting thing, this is where I put a double arrow. I want to nag about it more and say, the inside stays the same. I could write a big note about it, and I could say things like this. I could go, the inside stays the same, and nag about it and go, well, if you're in my class, I'd nag about over and over again. The inside. So here's the word cos, or the word sine, the concept cos, the concept sine. That bit that's inside the brackets, I even say it inside the bracket, so I refer to as the inside. Inside stays the same, it doesn't change. So we've got a 3x plus 10. Let's have a look what happened. The cos just became a sine, but we say, where does a cos come from? A cos came from the sine, so we don't need to put a minus there. Don't forget to go plus C. There's more to this question though. You have to divide by the derivative of the inside. So how do I divide by the derivative of the inside? And we can look at y. I could go through that in a minute. So for the moment, it's just the basics of what's going to happen. The derivative of that is 3. And that's to make up for the fact that if we were differentiating, you times by the derivative of the inside. So we're going to make up for the fact that would have times by the derivative of the inside, but we're reversing the process. So we're dividing by derivative of the inside. Now that makes a lot of problem for a lot of people. They don't take it in. And they have other little expressions like evil integration divides. So I talk about being evil. And while I talk about it evil, it's often just gets this little complication about it, which many students forget to have that divide by 3. So to try to get students to remember, I call it evil integration divides. Divides by what? Not by the 4. divides by the derivative of the inside. So let's have a look at the next one. Tried to make it more complicated, went for a fraction, went for a negative, and swapped that around the other way just to see if it mucks people up. Only because people will do it to you in assessment. So, where's a sine come from? A sine comes from a minus cos. A sine comes from a minus cos. But we haven't got a sine, we've got a minus sine. So a minus sine comes from a cos. So you take your time on that. It takes a while to sink in. Myself, when I first learned at school, I wouldn't think about that. I'd just say, there's the half, don't have to think about it. Sine comes from a cos, don't have to think about it. That stays the same, 2 minus 5x, don't have to think about it. Put the plus c, and you go, uh-oh. First of all, I've got evil integration divides. So what does evil integration divide by? The derivative of the inside. So the derivative of 2 is 0. The derivative of 5x is 5. So that's a minus 5 on the bottom. And look at the complications going to happen now. So this inside will give us a minus, plus also, if I differentiate cos, I get minus sine. So you go, that's okay. I differentiated cos, and I got a minus sine. But I've also got another minus 5 here. And this is where you got like those negatives make a positive and all that stuff happening. Now, I've found so many people struggle with a fraction divided by a fraction. They don't know what to write. So I'm just going to write this for a moment. I'm going to leave space for a number. I'm just going to write the cos 2 minus 5x plus c. And there's going to be heaps of people out there who have no problems with going, what is that? So if I just went over here, I'll rub it off in a moment. If I had a half divided by minus 5, or even if I leave out the minus, let's just put the minus over here. There it is there already. Let's go just a half divided by 5. How do you do a half divided by 5? How do you write 5 as a fraction? Over 1. And we're back to, what do we call it? Invert and multiply. Oh guys, my video's becoming too long. There's no way around it. So the half stays the same, the divide becomes a times, that goes upside down, you've got a fifth. And then you've got multiply the tops and multiply the bottoms, you've got a tenth. So our fraction at the front here becomes a tenth. All I do when I think about it, apart from that minus, if that's 5 over 1, 5 over 1 on the bottom becomes 1 over 5 on the top. So 5 over 1 on the bottom becomes 1 over 5 on the top. See, lots of people do all sorts of stupid things. Very common for people to write 5 on 2, because they don't know that when you divide by a fraction, invert and multiply, to turn it upside down. Just rub that off so I have room for the next question. So that one's done. As long as you remember to put the plus c. So that got a bit fiddly. Actually, that got more fiddly than this one. This one over here, I've added an extra x in. It's just extra. What does that do to your brain? I find for a lot of students, you put in extra, and it's like they've never seen it before, or they freak out, they're going, I don't know what that's there for. How do I integrate an x? It's just an x squared on 2. Increase the power by 1 and divide by the power. So that's got nothing to do with the sine or cos over here. So let's have a look what's going on over here. I know it's going to be a minus 4. Well, it could turn out to be a positive. I know cos becomes a sine or comes from a sine. Then you've got to check with things and go, wait a minute, the inside stays the same. I should have written over here, the inside stays the same. And we know we're going to go plus c. It's almost like an annoying logical process. Some people out there go, oh, why do you do that first? And ready for it? So the minus 4 stays there. It's there for the ride. Cos comes from a sine. So if I cover over the negatives, cos comes from a sine. Could do this though. Minus cos comes from a minus sine. Mind you, I can teach that, but I didn't think it myself as a kid. I just go cos comes from a sine. And I go minus cos comes from a minus sine. Depends on what works for your brain. Now back to my evil integration divides. What's it divide by? And oh my goodness, this mucks people up. That number in front of the x is the coefficient of the x. Over here, the coefficient of the x was the minus 5, so we divide by minus 5. Just remember, pi is just a number. It's a bit over 3. Of course, we can quote decimal places. So you divide it by pi. And there's the question finished. Don't need to write anymore, don't need to tidy it up. If the question said write it in a certain form and they wanted it as a half x, and they wanted this as minus 4 on pi, you could muck around with it. But the question's done. Just remember that pi doesn't cancel. Remember I talked about that being the inside. You can't cancel an inside with an outside, like square roots and all sorts of things. You just can't cancel anywhere. Well, I hope that helps. I'm going to have a look at a couple of the more complicated cases that really muck people up next.